A. Okay, let's look at part B. So for part B, we're looking for a formula, not just a single answer. Okay, and so for B we're going to have a formula, and that formula is going to involve the concentration of dopants as you go down through the surface. And so it's based on the initial dose, QT, divided by the square root of pi, and then also divided by dt. And this one will be at after the drive-in step, so that's the 1200 degree dt, times the an exponential term, e to the minus z over two square root of dt. Okay, so let's figure out that formula. So I know this value, right? We just calculated up here, so that one comes down here. And square root of pi is constant. We know this value. We used that. We already calculated that, and so we can use that. It's 0.78 microns. And then the z is going to stay there as part of the formula, and oops, I made a mistake when I wrote this, so it's really this part squared and z squared. Okay, have to square those values. Okay, so let's plug in our numbers, and we have I think I'm going to rearrange this a little bit. This part is going to be e to the, if you remember, z over 2 square root of dt, a quantity squared. Okay, so I'll do that little bit of algebra. The top squared, or the numerator squared, the denominator is squared. You can pull out that squared term, and so you have numerator over denominator, and the whole thing squared. Okay, part of one of the exponential rules. And so the answer is expressed in this form, so I'm just going to jump right to it now. So 6.99 times 10 to the 15 per centimeter squared, divided by square root of pi. We already calculated that out to be 0.778 times 10 to the minus 4 centimeters. And this is going to be times, now our exponential term, e to the minus z over 2 times our dt value, which is 0.778 times 10 to the minus 4 centimeters. Okay, and that whole thing is going to be squared. Okay, so simplifying this, feeding it through the calculator, let's see what we get. Okay, so I have 6.99 e to the 15th divided by the square root of pi divided by 0.778 e to the minus 4, and that part is equal to 5.069 times 10 to the 19th power. So our formula becomes 5.069 times 10 to the 19th, and the units on this are per centimeter cubed, per cubic centimeter. times e to the minus z squared, and I'm going to figure out this bottom part. So I just take 2 times 0.778 times 10 to the minus 4, and that comes out to be 1.556 times 10 to the minus 4 centimeters, or if I go to microns, this will come out to be in microns 1.556. So this just goes away, and I have 1 point, or I could round that to 1.6. Although again, if you're using exponentials, it's not a good idea to round too early. So we might want to carry 1.556 out a few decimal places before we process it through the exponential, because that's going to change your number quite a bit. Any rounding errors are going to be amplified exponentially by this factor. Okay, and so that's that part, and so then so that's the answer for part B, is actually a formula, not just a number.